Question 8. Particle of mass 10 rests on a horizontal table, and another particle of mass 6 rests on another horizontal table as shown. So we come up here to the question, the diagram. They're connected by a light and extensible string which passes under a movable pulley of mass 20. We can see that the 20 is going to go down with an acceleration of the average of the other two. 10, well, they're both going to move in, so we'll have 10 going that way with an acceleration of A, and we'll have 6 going that way with an acceleration of B. Find the tension and the acceleration of the particles and the pulley. Okay, so let's look at my 10. My 10 is on the table. We're told there's a coefficient of friction, so we have mu r going in this direction. I have my reaction, mg. This is my 10, so I have 10g. I'm moving in this direction with A. I have this tension in the string. So I start by saying R is equal to 10g. So mu r is equal to, it's a half here, so a half of 10g, which is 5g. So that's my mu r. So now my force is T, starting with T, it's going to the right, minus mu r is the only thing stopping it, so minus 5g is equal to ma, so 10a. If I take my 6 going in this direction with an acceleration of b, I'm just going to put my r in first, put my b in here. We have coefficient of friction between each particle on the table is a half, so I have mu r going this way too. I have mg, which is 6g, and I have the tension in the string. So again, start, my reaction is equal to 6g. Mu r is equal to 6g times a half, which is equal to 3g. So starting in the direction that it's going, which is t, so I have t minus mu r, which is 3g, is equal to ma, which is 6a. And then my 20 in the middle, which has two strings. It's going down with an acceleration of a plus b over 2. And mg going down is 20g. So starting with my 20g, I have 20g minus 2t is equal to m, which is 20 times a, which is a plus b over 2. So 20g minus 2t is equal to 20 divided by 2, which is 10. So 10a plus 10b. So if I can get my a and b's in terms of g and t, I will be able to solve this. So up here, a is equal to t minus 5g over 10. And did I call this a? I should have called it b. Just here, easy mistake to make. So b is equal to t minus 3g over 6. So we fill those values in. 20g minus 2t is equal to 10 times t minus 5g over 10. See, the 10s will cancel. Plus 10 times t minus 3g over 6. So I've got that 6 over 10. So that's, if I multiply everything by 6, I can just multiply that by 10. So I'll multiply everything by 6 here to get rid of the numerator or the denominator. So 120g minus 12t is equal to, we get the t minus 5g here, but I'm going to have to multiply it by 6. So I'm going to get 6t minus 30. And then the 6, if I put it here, it's going to cancel with the 1 on the bottom. So I'm going to need to multiply by 10 to get to plus 10t minus 30g. So solving for t, I have 10t, I have 6t, I have 16t. I'm going to bring over 12t to get 28t. That's going to be equal to 120g I should have had a G here, just seen I missed it out. And I've got minus 30, minus 30, minus 60, which I'm bringing across to 120 to add it to get 180 G. So the tension is 180 G over 28, which is 90 over 14, which is 45 G over 7. And that's newtons. And 7 goes into G 1.4. 45 by 1.4, I'd have to add 18, so that's 63 G. Does that work out? 63 newtons exactly. 63 newtons exactly for tension. And we were also asked for the accelerations of the particles, the tension and the acceleration. So we're asked for A and B, which we have up here. Get them in shot. A is equal to T minus 5G over 10. So A is equal to tension 63 minus 3G over 6, and B is equal to 63. No, that's wrong. That's my B. 63 minus 3G over 6. A is 63 minus 5G over 10, and these work out to be B to B. 5.6 meters per second squared, and this is going to be 14 over 10, 1.4 meters per second squared. So that's number 8. Number 9 we'll do in this video as well. Two masses we can see here with the 68 and the M. So what are we told? Coefficient of friction is a half, connected by a smooth string, extensible string, and we just have this M kilograms. That's all we have. Show that none of the particles will move. None will move. So acceleration 0. If M is less than or equal to 6. And then if M is 12, find the accelerations of the particles and the movable putties in terms of G. Okay, we have our 6, our 8, and our M, and friction is a half. So we have our 6, our 8, going in this direction. Friction is a half. And we have the mass with 2 strings of M, mg, to big M, and acceleration of A, acceleration of B, and acceleration of A plus B over 2 in that direction. So, or 6G. We have mu r, so r is equal to 6G, so mu r is equal to a half times 6G. Mu is a half, which we brought down from the question, so mu r, so that's 3G. So my equations, I have my tensions and my strings. I have my direction of A, so I start with T, so T minus mu r, T minus 3G is equal to MA, which is 6A. So on to the 8, again, mu r, and we have r, we have 8G, r is equal to 8G, mu r. You could write 4G if you wanted to write 4G because you've already used the half. So then my equation of motion, I should have put my T's up here, is T minus mu r, 4G, is equal to MA, which is 8A. No, it's not, it's 8B. And then for the mass M, we have the direction mg minus 2t is equal to ma. So big M by A plus B over 2. What are we asked to show here? Acceleration is 0, isn't it? Show that if none of the particles move, if m is less than or equal to 6. Okay, if m is less than or equal to 6. So we're asked to show that if none of the particles move, if m is less than 6. So we're kind of going back to the starting point that if m is like 1, 2, 3, 4 and it's not moving, it gets to the point where it's about to move. 6 moves first before it gets to a speed where 8 is going to move. So in fact, with the initial equations, these three equations that we have here are when the system is moving. But this equation, mg minus 2t, we don't have acceleration of b yet. So it's the acceleration is just going to be the a on its own divided by 2 for this a here. It's going to be, if a is this way, then the acceleration of this guy going down is going to be a over 2 because of the two strings until this guy starts moving in this direction. Then we have b involved. So at the moment there's no b involved to show that m has to be equal to 6 for it to move. So what have we got then? We just have these two equations with a in them and g in them. So why don't we solve for acceleration being equal to 0, and then we can see, can we get a value for m? So acceleration being equal to 0, if we get rid of our t's, that'll be a good way to start it. So multiply this by 2 to get 2t minus 6mg is equal to 12a. So I'm going to get mg times 1, that's mg minus 6mg, I'm going to get minus 5mg, mg minus 6mg is equal to ma over 2 plus 12a, ma over 2 plus 12a. I want to solve for a, so I'm just going to multiply by 2, minus 10mg is equal to ma plus 24a. So if I factor out my a, m plus 24, I'm just seeing my mistake that confused me here. It's mg minus 6g here, so they're different. We have mg minus 6g on the left. I was looking at it, confusing myself. Mg minus 6g. So we're going to have, well, I'll leave the mg minus 6g. I could factor out the m and leave g, factor out the g and leave m minus 6. So g times m minus 6, that's more like it. So my acceleration is equal to g times m minus 6 divided by m plus 24. And for acceleration to be 0, for a to be 0, the denominator has to be 0. So g times m minus 6 is equal to 0. G is 9.8, so that means that m minus 6 is equal to 0. So m is equal to 6, which is what we were asked to show all the way back up here. And then if m is 12, find the accelerations of the particles on the movable pulleys, right? So if m is equal to 12, so we sub 12 back in to this equation here, we're going to get 12g minus 2t is equal to 12 times a plus b over 2. So 12g minus 2t is equal to 6a plus 6b. Now we need to sub a and b back in. So we have this equation here. B is equal to t minus 4g over 8, and a is equal to t minus 3g over 6. And I'll just change colors because it's getting a bit bluey. Okay, so we have 12g minus 2t is equal to 6 times t minus 3g over 6. So cancellations, and plus 6b, 6 times t minus 4g over 8. So I need to multiply by 8 to get rid of this denominator here, which will, so I'm going to get times 8, 96g, minus 16t is equal to 8. I'm multiplying this guy by 8, 8t minus 24g. And if I multiply this one by 8, they cancel, leaving me with the 6, so plus 6t minus 24g. Apologies for the untidiness. So let's look to solve for t here. I've got 8 of them. I have 6 of them. I have 14, and I'm bringing over 16. So I have 30t equals, I have 96g, 24, and 24. I'm bringing over 48, so that's 144g. So the tension is equal to 144g over 30. And that works out to be 24g over 5. I think we're asked to find A and B, are we? Back through this scrolling mess. Find the accelerations. We weren't asked to find t, but we needed to find the accelerations. So we have A and B in terms of t. To find the accelerations, A is t minus 3g over 6. And B is t minus 4g over 8. So A is going to be 24g over 5 minus, well, I'll put this over 5, minus 3g, which is 15g over 5 over 6. So that's going to be 9g over 5 over 6, 9g over 5 over 6. So the 5 and the 6 go on the bottom. So 9g over 30, which we can divide by 3 to get 3g over 10, ms to the minus 2, and b is equal to 24g over 5 minus 20g over 5 divided by 8, which is equal to 4g over 5 over 8, so 4g over 5 by 8, 4g over 40, which is g over 10. And you can write it as ms to the minus 2, or meters per second squared. So that's those two questions. Quite a long video, 17 minutes. You can see they do get progressively longer. That was question 8 and 9. And 10, was it 10? No, just 8 and 9. So 8 and 9, we're going to 10 in the next video.